I've become very interested in the optimum geometry of the memory palace. I mean, why is it a memory palace and not a memory bungalow? You know, why isn't it a memory highway? What's going on here? And there's something very interesting about the palace, right? Because it has all these niches and cubby holes and rooms and floors. And there, what I think there's something being suggested to us about the optimum encoding necessary to perform at a very high level. And that encoding I'm trying to characterize in terms of, now I'm going to get a bit nerdy, the compressibility of a shape.
What's up, everybody? From Nautilus, I'm Brian Gallagher, and you're watching Behind the Scenes. Today I'm speaking with David Krakauer. David is an evolutionary biologist and the president of the Santa Fe Institute, a nonprofit theoretical research organization focusing on complex systems. In his research, he explores the evolution of intelligence and stupidity on Earth. This includes studying the evolution of cellular, linguistic, social, and cultural mechanisms and artifacts supporting memory and information processing. He was the founding director of the Wisconsin Institute for Discovery, the co-director of the Center for Complexity and Collective Computation, and the professor of mathematical genetics, all at the University of Wisconsin in Madison. His recent story in Nautilus was The Cormac McCarthy I Know. David, thanks for joining us.
Thank you. It's wonderful to be with my friends at Nautilus.
Great to have you as well. To start off, would you mind summarizing your background intellectually for our viewers?
Oh, yeah, that's a bit tall order. So I have training essentially in biology, computer science, and mathematics. And, and my work has basically been focused on the evolution of inferential representational mechanisms in nature, meaning how does the natural world arrive at computation? And that could be at the very lowest levels of molecules, all the way through to societies. And computations sometimes go well, and we call that smart, and they sometimes go wrong, and we call that stupid. And so it's that space that I'm interested in.
How did you get interested in following that line of research?
You know, it's interesting. I was always, as a teenager, interested in these issues. I was always interested in how we encode reality. It could be art, in fact. Why we choose to represent things the way we do. Why perspective? Why fixed point? Why platonic solids? Why imaginary numbers? Why genes? I've always been fascinated by the way that the complex world, meaning the living world by and large, encodes the reality in which it lives and how it uses those encodings to solve problems. And that goes back, it's interesting, it really does go back to my very early, almost single digit years. But at that point, I had no idea, obviously, that there was a community of people, complexity scientists that we call them now, who are all interested in that kind of thing. I guess the challenge was to navigate the strictures and constraints of the disciplines that think in very different ways, tend to think in terms of the empirical properties of a given domain, the physical world or the biological world. I don't think that way. I think in terms of these principles that seem to apply very broadly.
Can you remember back when you were that young in your single digits, what was the sort of first thing that really captured your imagination about the sciences or the natural world that got you to pursue this as a career?
Yeah, one thing, I mean, probably several, probably, watching Thunderbirds or something, some crappy television show. That's probably the truth. But I do remember my mum giving me as a Christmas present a book that she had found remaindered in a bookstore in London, Foyles, I believe it was. It was a book on expert systems. And so people probably don't remember this, but that was all the rage, in I guess, in the 80s, late 70s perhaps, to create, in some sense, smart databases that could replace doctors or engineers of, you know, at some kind of nuclear facility or what have you. And I remember being completely incapable of reading this book. I mean, I had no idea. But I loved it. It was kind of talismanic for me. So I would just look through all these pictures of various decision diagrams and bits of code. And I did have a strong sense then that whatever that book was saying, I wanted to understand. And so that was very young. And it was sort of, so it's both the field, the area, but also this kind of bookishness, this, there are secret sources of knowledge in the world, and you have to acquire the expertise to be able to read them, almost like these sort of sacred Sumerian scripts. So I was always very enamored of that idea that of esoteric sources of knowledge that you'd have to work to come to understand and appreciate.
All right. Well, once again, your recent story in Nautilus, the Cormac McCarthy I Know. Could you give us a brief summary of it for our viewers who may not have read it?
Yeah, so this is very personal. I mean, I've known Cormac for over 20 years. And over the years, I had read and heard a great deal about him from people who don't know him. How misanthropic he was, how reclusive he is, how mean-spirited. And it just seems so far from the man that I know, and have befriended. So part of it was motivated by just a desire to set the record straight on who he is to people who know him well. And the second part had to do, of course, with the release of his new box set of novels, The Passenger and Stella Maris, which we've been discussing, at least the content of that, since their inception, and the community and ideas that he's been living in that have informed that book. So it's kind of two things. One, personal, and the second, look, this is stuff that he's been worrying about for a long time, and let me tell you a bit about it.
Of course, we should mention for anyone who hasn't heard of Cormac McCarthy, he's a very renowned novelist of The Road and other books. When did you first meet Cormac?
I met him when I first arrived at the Santa Fe Institute. I was working at another institute, a lesser institute, called the Institute for Advanced Study in Princeton. And I was invited out as a researcher at the time, just to visit. And I was so impressed by the place. It was just, as a child, you dream of these places that are, they're almost like secular monasteries. And Neil Stevenson captured the sort of vibe in his wonderful book, Anathem. And when I came out onto the top of this mountain in New Mexico, I just fell in love with it. And it was that visit when I first met Cormac, and of course I'd read some of his books by then. And he was just a kindred spirit. This is a very curious mind, kind of voracious in his interests, and very giving of his time. And so just someone that I naturally was drawn towards.
Could you also give us a brief description of the Santa Fe Institute itself? What does it focus on, and how did Cormac come to be there, given that he's not a scientist?
Yeah, so the Santa Fe Institute is in Santa Fe. People ask me, where's the Santa Fe Institute? It's in Santa Fe, New Mexico. And it's here because Los Alamos is here. The institute was founded in the early 80s, 83, 84, by a group of extraordinary physicists and economists, and chemists, actually, who in one way or another had been attached to both Los Alamos and the Manhattan Project, and that's a very interesting history. But they wanted to apply deep mathematical computational principles and techniques to the complex world, not the simple world of physics, the world of invariant form, structure, and process, but the evolving world. And that could be, behavior, civilization itself, language. And they came together to form that place, and there were key figures like Murray Gell-Mann and Ken Arrow and Phil Anderson and George Cowan, the founding president, who'd worked with Enrico Fermi at Chicago and then became the director of chemistry at Los Alamos. So that crew convened this culture where they wanted to apply this extraordinary, rigorous, mathematical, natural scientific tradition to a world that was messy. And what would it take? What new methods would we have to invent? What kind of community does that require? I mean, we clearly could not recapitulate departments and disciplines. It's just a bad fit to the problem. And so it was a very interesting experiment in creating a genuinely novel epistemology and institution responsive to the needs of the complex world. So that's what SFI is and remains. Cormac had been a recipient of the first year's MacArthur Award in 1981. And one of the founders of the MacArthur Genius Award, as it's called, was Murray Gell-Mann, one of our founders. And they became friends. And so when Murray and others were conceptualizing SFI, it was very natural to invite Cormac to sort of be a part of that community, because he was obviously very curious. And Murray had been a reader as a young boy. He'd always wanted to be an archaeologist, in fact, before he became a physicist, and won the Nobel Prize in 1969 for the Eightfold Way. So he was broad, and I think he felt that it was important to establish a kind of porous, open-minded culture right at the beginning and not do it later, right? Most people say, okay, we've already developed our silos and now we're going to be interdisciplinary. But by then it's almost too late.
So his new pair of books are coming out soon, or I think so. Not sure if they're already out, but Stella Maris and The Passenger were the release of those books, or their impending release, part of the inspiration or the impetus for writing about your long relationship with Cormac now?
Yes, for sure. It's interesting. 5 years ago, Cormac and I had a conversation in the SFI library, filmed by a friend of ours, a Polish film director. And we sat on that for quite a while, partly because the book had been delayed and we were waiting for that book to come out in order that the conversation would be relevant to the topic. And that was released, and I think of some interest to admirers of his work. And in fact, because I've had this long-standing relationship with Nautilus, I'm on the editorial board, I love this magazine, Kevin Berger wrote to me and said, well, would you like to write a more personal piece about your relationship with him as opposed to, this interview format? And I sort of jumped at the chance to do that for the reasons I gave at the beginning.
In the piece, you write that percolation theory is a fixture of much of the science produced at SFI, at the Santa Fe Institute. It is almost a metaphor for the connected collegial way we practice science. What do you mean by that? And could you explain what percolation theory is?
Yeah, so that was one of those slightly enigmatic paragraphs in the piece. And so physicists have for a long time been interested in how, for example, a fluid might flow through a porous material. And you can imagine if the material was too dense, it would not. And if it was too loosely bound, it would just flood it. And there's this sort of critical density where fluid forms these rivulets that connect all parts of the space of the material. We'd call it a space-filling structure, like a fractal. And those insights have been generalized to network theory, for example, where you take, I'm assuming the audience of Nautilus is familiar with a network, but you have nodes and they're connected by edges. And you can say there's a certain probability that a node would be connected to another one by an edge. And at a certain magical number, a certain magical probability, that network becomes connected in the same way that that material is connected by those rivulets of water or fluid in the porous medium. And these are called percolation thresholds. It's a critical point at which a system shows long-range order. And it's a sort of metaphor, I think, for the state that an institute like this wants to be in. If no one talked to anyone else, then that would be useless. We might as well be in cabins. There's no benefit of being collective. If we were all connected to everybody, we'd be sort of flooded by too many obligations, too much information. But there's this kind of magical connectivity where you are connected enough to benefit from the collective intelligence, but not too connected to be overwhelmed. And this idea, I think, of reaching that critical percolation threshold in an institution was of interest to me. And so that's why I used it as a metaphor in the piece.
How well do you think the Institute is realizing that ambition?
Very well. No, I think, really, I'm biased, of course, as the president, but I think very well. I think that's one of the things that we do is we achieve this more or less effortless connection between archaeologists, quantum mechanists, nonlinear dynamics researchers. It's a very interesting structure that I think is required to solve the kinds of problems that we're facing in the early 21st century. And I don't think that the world's problems are disciplinary problems anymore. I think they're these highly connected problems, which requires a sort of corresponding innovation in the kinds of institutions that support research.
What's an example of that sort of problem, and what's an example of a recent piece of work that really showcases that interdisciplinarity?
Yeah, just I hate to do this, but COVID, I think, was illustrative of exactly the problem. Here was a virus, and it infected many people in the world to deadly effect. But this virus was also, in some sense, a contagion of the social systems of the world, of the economic markets of the world, of the mental well-being of the population of the world. We treated it as a disease like any other, but at the scale at which it operated, it took on these new characteristics. And what we witnessed was extraordinary expertise in immunology, epidemiology, in vaccine development, but no concomitant proportional degree of rigor in our economic thinking or in our thinking about the healthcare system or the educational system, with all these kids being stuck at home with potentially long-lasting psychological consequences. That was an example, I think, of both the success and failure of the disciplinary model. And so at SFI, our response was to say, we need to start building models and theories that integrate both the basic transmission dynamics that would be familiar to epidemiology, but also aspects of the economy or of the educational system. And that kind of integrated reaction, I think, is what we were missing, actually. And it's a pathology of the way that the world is currently organized at the scholarly level.
So I want to go back to one of the enigmatic things you mentioned in the piece on Cormac. So mentioning Frank Lloyd Wright's self-designed home, you describe it as geometric, claustrophobic, and animate, as if evolution started with axioms rather than finishing with them. Could you unpack that a bit more?
Yeah, no, it gets back to my early interest in certain kinds of structures. And, there are these two ways, I guess, of designing beautiful things. You can sort of allow the materials and constraints of the form dictate its ultimate trajectory. Or you can start with a set of very fundamental principles, as one does, for example, in pure mathematics, and everything is deductively arrived at. And I think what's of interest about Wright is he has both qualities. He has this geometric deductive quality. They look like these Tetris blocks, right, in the natural landscape. But at the same time, they have a kind of animate quality by virtue of the modesty of their scale, their color palettes, their being subsumed by landscape. And so he strikes a chord, I think, with our community, which on the one hand is interested in, if you like, the sort of crystalline 0 degree Kelvin world of deductive mathematics, but on the other end of the spectrum, the sort of Darwinian, evolved, organic character. And how do you reconcile the two? So Wright is almost a kind of a symbol of that reconciliation. So that's what I was trying to convey.
Hmm. Can you tell us about any more interesting tidbits or anecdotes or ideas that, for whatever reason, you didn't end up including in the story about your relationship with Cormac?
Well, yeah, I mean, it's interesting. I mean, there's so much, right? But um, one of the things that I thought about mentioning, but I simply didn't have the space, was this shared interest in the history of polar exploration. One, if you like, sort of meta theme in many of our conversations is risk, and in particular, existential risk, the risk of death. And there are these personalities around the end of the 19th century, beginning of the 20th, and I'm thinking about people like, Amundsen, Nansen, Robert Falcon Scott, Shackleton, Byrd, polar explorers. And their lives and what they were doing that seemed, on the one hand, so pointless and at the same time so epic and laudatory. But the connection to that world and science. I mean, Cormac's favorite adventure exploration book of all time by a long shot is absolutely Cherry Gerard's The Worst Journey in the World. And that book was the, if you like, recollection and biography of Scott's Terra Nova expedition in which Scott died. And the purpose of that trip was to, well, there are many, but the scientific purpose was to test a theory, a scientific theory, which was the so-called recapitulation theory, which is that during the development, say, of a bird or a mammal, a multicellular organism, you recapitulate the evolutionary stages of the lineage that it belongs to. And in order to test this, they were in search of the egg of the emperor penguin. And so all of this heroism, the end of empire, the beginning of the First World War, just prior, was in the service of this very esoteric scientific question relating to the nature of development and evolution. And that conjunction is something that has fascinated us forever. And the story is, of course, is they did manage to get this egg back, and by then the theory had more or less been rejected, and the egg was deposited in this warehouse at the Geology Museum that always reminded me of that scene at the end of Indiana Jones, if you remember, where they've recovered the Ark of the Covenant, and it's this most miraculous artifact, and yet it's just one of millions of similarly powerful objects. So that's something. And then, of course, the other side to that, other explorers who were taking other kinds of risks. I mean, notably Charles Darwin, when he was 22 on the Beagle in the 1830s. And once again, this kind of ingenue character that interests Cormac a lot, who had defied the wishes of his family in order to sail as the naturalist on the Beagle, the long voyage, but along the way made this discovery that was basically earth-shattering, changing our relationship to the rest of the living world. That kind of person interests him a lot. And also then as I mentioned in the article, the young quantum physicists. And they weren't taking existential risks themselves, but they were putting the planet at existential risk because the consequences of their theories were the atom bomb. And I think that combination of the individual life, the mission, if you like, curiosity, and how it sometimes leads society to the precipice is a constellation that is of great interest to Cormac.
Speaking of adventures and existential risk, what do you make of that, the intellectual landscape of trying to assess what are our existential risks and what are the moral imperatives of dealing with them? Like one of them is um, the necessity of becoming a multi-planetary excuse me, species, like it's starting colonies on Mars. Do you think
Mm.
that that is a wise pursuit? Something we should be really focused on?
Yeah, I think that that's a very poor justification for space travel. It's kind of ludicrous. And there are really wonderful justifications for the exploration of space, and which I buy. And we, as you know, I mean, we have our own interplanetary festival, so we're very committed to this, the exploring the boundaries of what consciousness can do. And I think to remain content with the data that we might be able to collect and observe on the surface of our own planet is limiting the open-ended spirit of the human imagination. I think that's a great justification. And I think, and there are sequelae to that pursuit, which society benefits from. And that's the usual argument, the utilitarian argument, the Apollo guidance computer was the first miniaturized transistor computer, and we benefited from that and all that. And that's wonderful too. But this idea that we're somehow going to escape is a really poor justification for the progress of the imagination and scientific research.
Can you say anything about the impact your story has had? Have you are aware of any kind of response to the piece, and what sort of feedback have you seen?
And I don't know. It's very funny. You would know this much better than me, Brian. Don't tend to be very good that way. I have friends who've written to me and pointed out their own experiences with Cormac, mutual friends, and by and large, it's been delightful. I mean, people have been very kind and perhaps surprised by the sort of I don't know what to call it, mischaracterization of this person. And I was talking to one journalist in Norway who was really thoughtful, and she was asking me exactly that question about, that he's this sort of hermit. And as I pointed out to her, and I wrote in the story, he's not a hermit, he's just selective. And presumably when you reach that level of fame, you have to be, otherwise you'd be overwhelmed. And so I think his readers grudgingly accept that characteristic because they're appreciative of the time it gives him to produce the work that they admire. And so I just wanted to help people understand that he was not an ogre, that he's a genuinely generous person and engaged in difficult thinking and writing books that people love.
Can you share with us any projects or research that you're working on at the moment?
Well, yes, I've become utterly obsessed with the limits of human performance. And I've been working for the last several years on Rubik's Cubes and memory Olympiads. And the thing I got very interested in is the following, and it's maybe a little bit nerdy, but anyone
By
who...
all means.
Okay, so it's the right venue to talk nerdy stuff, right? So anyone who has competed in a memory competition or solved a Rubik's Cube blindfold, that kind of thing, has to use something called the method of loci or a memory palace. And Jonathan Safran Foer wrote a very nice book about that called Moonwalking with Einstein, about trying to learn to be a great memorist. And These methods of the memory palace were invented a long time ago in the classical world, but made famous by Giordano Bruno in the 16th century. And the idea is that you develop this giant internal model of a complex structure like a palace, a church, a cathedral, and then you place objects around it, and each object is associated with a number or a color or a shape. And by navigating through this memory palace, you're able to recollect a particular sequence that you're supposed to produce in competition. It could be a list of natural numbers, a list of dates, and so on. I've become very interested in the optimum geometry of the memory palace. I mean, why is it a memory palace and not a memory bungalow? You know, why isn't it a memory highway? Well, what's going on here? And there's something very interesting about the palace, right? Because it has all these niches and cubby holes and rooms and floors. And what I think there's something being suggested to us about the optimum encoding necessary to perform at a very high level. And that encoding I'm trying to characterize in terms of, now I'm going to get a bit nerdy, the compressibility of a shape. And just to finish on this, the worst memory palace would be a featureless circular room, right? Where you couldn't tell where the points of the compass were. So where did I put the object? I have no idea. It's infinitely ambiguous. So you can start to see if you break the symmetry of the circle and made it, say, a square, and you said, well, I put it in a corner, you'd be right 1 in 4 times. And there's some relationship between the way memory works and symmetry, and the symmetry of physical objects, actually. And so this is this weird pathway that I've been moving down over the last several months.
Is there any link to that and your research into stupidity?
Not on this particular topic. I have various links I could give you to prior work, and but this is new, and to be honest, quite struggling with it because it's a field that manifests as this extraordinary human ability, remembering tens of thousands of digits of pi, for example, and so it's very interesting, and yet the literature is very qualitative and dominated by techniques used by practitioners. It's not really studied much by scientists. And so finding a way to actually quantify and catalog the geometry of the memory palace and then connect it to the way memory systems work is a real challenge, a very exciting one. But my progress thus far, it's definitely not a palace. It's more like a sort of a mound. I'm heading towards something more elaborate and interesting, but it's slow progress.
It's interesting. I just came across a paper recently that argued that the fundamental function of the hippocampus is imagination, and that memory and spatial navigation are sort of applications of this more broader role of serving for imagination. What do you make of that?
Yeah, that's a very interesting area. So it used to be, I honestly, Brian, I don't know that work, but it was the role of the hippocampus was very hotly contested between the people who worked on humans and the people who worked on mice. And in mice, it had to do with the representation, let's say, of position. And in humans, to do with what we would call factor analysis, factorization, orthogonalization, separating signals. So you can sort of see how those things are related, because if you want to know if you're in point A or point B without ambiguity, you want to make them as different as possible. And so there's been this history of trying to find the most fundamental thing that a brain region does that doesn't rhyme with the thing that we think it does, but it's somehow the underpinning of that function. And the one you've just mentioned, imagination, I'm not sure what that would mean. It smells like that, right? You're trying to find the common denominator to a range of different affordances and abilities, which aren't the ability themselves. And that's very interesting. But Who knows? It's very intriguing, right? That the brain, like many complex systems, oscillates between being this general purpose device, right, on the one hand, and being this highly fitted special purpose machine. And we go back and forth all the time. But, cerebellum, hippocampus, maybe they're special. Prefrontal cortex, ooh, that's more general. And, it's a very intriguing dialectic that's centered on information processing machines. And it's recapitulated, by the way, in hardware. If you think about CPU versus GPU, GPU has that more, hippocampus cerebellum-like quality, where the CPU has that frontal cortex-like quality. And I'm not sure whether this is real or the way that we like to organize the world. It's a kind of emergent dualism in how we think about information processing. It's very curious.
All right, David, to close out, do you want to tell our viewers where they can find you online? Are you on social media or have a website people can visit and check out your work?
Yeah, I am not on any social media at all. The Institute is, but you can check out some of my work on a website, davidckrakauer.com, and there I sort of list, recent papers and articles and so forth.
All right, fantastic. David, it was a pleasure speaking to you. Thanks so much for
And
coming on the show.
oh, thank you so much for having me.